All right, let's go to video 8. Going to be given the angle in an area, or the area in an angle, we're going to find the missing sides. So what we're going to be doing now is substitution. We did a little bit when we derived the sine area formula and the law of sines and law of cosines in video 4. Let's take a look at the solution. This first case, we have area and an angle. Let's look at the solution. So what we're looking for is this leg, but we need more information. So we the tangent of 38 is equal to y over x. That's what I've written down here. That's a given, right? And then what we're gonna do is we're gonna solve for y. So if we solve for y, we'll end up with tangent of 38 times x is equal to y. We can replace that, and we end up with tangent of 38 times x. So now we have one variable. So 1/2 the x times the y is equal to the area. We know that from the triangle, right? Triangle area formula. So what we're going to do is we're going to say 1/2 of x, which is our unknown, times tangent of 38 times x, which is this height here, so the base times the height, is equal to 156.2571, which is our area. So if we have, so we're just going to rearrange this a little bit. 1/2 of tangent to 38 times x squared. Since we have x times x, we got x squared. And then we can start to solve. We're going to take, we only have one variable, so we're going to take 1/2 molded to the other side. So we end up with, multiply both sides by 2. We get 156.2571 times 2 is equal to tangent of 38 times x squared. And then we want to get x squared by itself. Divide that by tangent of 38 on both sides. We end up with x squared. And then we get the square root of all that, and we'll get equal to x. We end up with 20. So this is equal to 20. That's solved. Now we still need to know what this is. So, but we know it's tangent of 38 times x. So we can tangent of 38 times 20. So let's do that. Tangent of 38 times x is equal to y. So tangent of 38 times 20 is equal to y. And then y equals 15.6257. And I think I did that. And we're done with that. Suppose something else. Yeah, let's take a look at this. This is a curious case for me since I'm looking at it. Oh, here we go. So then there's 3 different ways to solve this. We could use the sine of 38 as 15.626 over d, which or whatever you want to call it, d or x. And then we solve it that way. The cosine would be 20 over x, 20 over d, and we solve it that way. I could go this squared plus this squared equals this squared. Use the Pythagorean theorem, and then you would solve all 3 of them to give the same result. And so here what we've got is a principle of area. It's a little difficult because if you look at screenshots, it's a little difficult to say. But anyways, we've got, I want to show you, illustrate to you why as the distance changes, the area is the distance squared. So if this is 10 and that's 20, the multiplier is 2, right? So we're going to multiply 10 times 2, and we're going to get 20. So let's just write that out. If you can see 2 times 10 equals 20. So we know the distance right here. That's what we do is we take the 30 times 2 squared, right? So you multiply it by the distance squared. So 30 times 2 squared. Let's write that out. 30 times 2, which is the distance squared, right? And then they'll give us, let's go ahead and put it in a calculator. 120. All right, and then let's go to the next one. 3. So it's real simple. T 10 times 3 equals 30, right? I'm going to do the same thing. 10 times 3 equals, I'll just leave it in purple, right? So the area, which is 30, times 3 squared, right? I don't know. Anyways, I thought I'd clarify it because it was always kind of a difficult one for me to apply. But then you can start to use ratios, and that's kind of what we're doing here. It's just done a little differently. So 2 times 10 is 20, and then let's do this one. 2, so 30 times 2 squared equals 120. Hope that helps. Like I said, I never really took the time to. I knew how to do it this way, so I never took the time to apply this ratio factor to my solutions. So if you've done that and you want to share it, that'd be great. The reason why I'm doing these videos is because I couldn't find them on the internet, YouTube in particular. So thank you, YouTube, for giving us a way to solve some of these problems. For me, a lot of these were just curiosities, but curiosities because of applying them in construction all my life. Specifically, any one of these may not have come up, but generally all of them, all these principles and all these have come up probably at least more than once. So this is mislabeled, isn't it? Control. Let's change it to 8, 9. I think, right? 8, 9. Yeah. Yep. See you on video 9.